He's a research scientist with in South Australia, based in Adelaide, has a career spanning 40 years. Prior to joining Centec, Michael involved placements at SIRA and the University of Adelaide, where he contributed to projects including carbohydrate metabolism, fetal growth retardation in sheep and humans, plant biochemistry and genetic engineering of wheat and barley. Michael's interests in plant physiology, soil, water and salinity now focus his research in the development of Centec's electronic sensors. This work involves the use of observable soil, water and ion dynamics throughout the root zone of horticultural crops as an indicator for the application of optimum irrigation and fertigation management strategies. We welcome you and thank you to the Simpfendorfers who suggested that Michael come and speak based on some trial work at your property. So, welcome, Michael.
Well, that's it. Thanks. Well, thank you for the invitation. It's great to talk to groups, particularly growers. It's really great to talk to people that are actually involved with the technologies that we supply. I'll try and make it not so marketing. I work for a commercial company, but I basically allow the equipment to sell itself, and I just talk about the science of it all, really. So you can ask any questions, but I may not be able to help you with some of the stuff like how much it costs and all that sort of stuff. I'll leave it up to other people. So the work that we had, essentially we started a research program with Simpfendorfers 10 years ago in 2014. We were wanting to test a new sensor that we were working on, looking for a difficult site, and they were quite keen to have us there to test out their soil. The sort of systems that we had at the time, they were using, they had nectarines there as well, so you probably noticed nectarines there straight away. You know a pistachio tree from a nectarine. So that's the sort of system that Centec provides. It's a soil moisture monitoring where we measure the volumetric water content in the soil on a profile basis. We measure the volumetric ion content, which is the amount of salts or fertiliser that goes through the soil, and we measure temperature at every 10 centimetres. So the probes, they have to come in a form like this. There's two different forms. This one's only a short one. There's a much longer version of this, which is 1.2 metres long. We use a patented technique to put that into the ground. And then we record the water contents. Sorry?
Is that called a sledgehammer?
No, we actually don't use sledgehammers on this one. On the previous one, we do. That's another lecture. But this system actually uses Bluetooth, so there's no cables or anything. That'll sit into the ground, and I can talk to that with my phone, and I can also inquire it with another piece of circuitry. I can ask it to download the data that it has and send it to the internet. So I don't have to go out to the field all the time unless there's some problem with the data. So that's the sort of system that we have. This one is actually not quite that advanced, but it uses the same technology as that probe there. The probe is in the ground, actually connected through a cable. That's 10 years ago, that was what we were doing at the time. So now we've moved on from that. Just a little bit about Centec, about per metre. per metre. Now exclusively pistachios. They used to have nectarines, as I say, but they went out of favour, so they've now concentrated on pistachios. Looking at 14.5 hectares, 3,500 trees almost, and spacing there for the people that like that sort of stuff. They use urea, potassium sulphate, and DAP. They used to use sodium phosphate, but sodium nitrate, or potassium nitrate, but now they're not using that so much. They use, as I say, next one. This is a bit. This is north. So, sorry, it just fitted on the way better. It actually fitted better on the slide that way. So we're looking at 4 blocks essentially: P1, P2. P4 and P5. Maha presented some work this morning that was taken on P5. We've now got a system there as well, and we want to be able to record the volumetric water content and the salt content and the temperature in the soil as well as in the canopy. That's the idea of the research, the whole thrust of the research. We have other systems here that we've had for various other studies, but we're now repurposing those to include in this study now. Next one. Pistachio varieties, for those people that love that sort of thing. Sorora is the one of choice. We've only got sensors in, as I say, 4 areas. These 4 areas, P1, P2, P4 and 5. I only have about 25 slides, so hopefully we'll get done in 20 minutes. So we've got under tree sprinklers, we've got the irrigation zones, we've got 7 irrigation shifts. There's actually about 11, I guess. There's P1 to P10 plus the another variety. So we've got 11, if you like, different shifts, but that's circulated on 7 irrigation shifts that they moderate. And each one of those is sort of 1 to 2 hectares each, so it's quite manageable, I suppose, you call it. Collaboration history with Centec, as I say, we started in 2014. We've used the site to look at drill and drop. This probe is called the drill and drop. At the time it was the Project D, but now it's called drill and drop. And that probe was partly developed at this site. We used these hard saws with lots of carbonate in the bottom and stones to really test us out. And there I am actually bending that probe, so you can see the sort of testing that we had to do in this. These probes are $1,200 each, and I was there trying to break them, which was fun for a period. And we had to essentially develop our own tools for that through Mr. Peter Tucker in Renmark, who has now departed us. But those tools now live on without him. We have also looked at temperature dependence, so we know that capacitance technology is dependent on temperature, and we have a correction for temperature in all our probes to do that. The slimline probe is another probe that we have that goes to 1.5 metres. It's a deeper installation than we previously had for drill and drop, and that was partly studied at per metre to do that research. The site is really good because it's a mixture in soil textures. We have a difficult carbonate layer to play with. We also wanted it to be able to look at salinity, but Martin and James were less interested in salinity because of the pistachio tolerance. But it's really useful to look at fertiliser. So if you're not looking at salinity, you can actually trace some of your fertiliser. Depending on the soil, obviously it's better if it's mostly soil, but works okay in this sort of soil. James and Martin's main concerns, getting enough winter chill portions, so that's obviously we heard about that this morning with Maha's work. He's having extra disease pressure in rainier than usual years, so we're seeing part of the climate change coming through, part of the problems associated with that. It's got the onset of insect pest problems from previously non-problematic species. Of course, everybody struggles with the aflatoxin at various times of the year. That's a worldwide problem from Aspergillus flavus and parasiticus, just a mold infestation in the nut. And we get this dieback in spring bud burst. We're trying to all grapple with. But I think, like all things these days, most of the easy questions are solved. It's the hard ones that we've got to work on now, and that's a hard one. I think our approach has probably got to be broadened a bit. We have to get a lot of sensors out there, get a lot of different parameters out there, and try and use some statistical analyses to actually try and link those things together, because you can make models on this sort of thing, and there are departments that we work with too that do that sort of work. They essentially take a whole lot of random variables and say, okay, what's the connection between them all? And that's the sort of thing I can see this developing into. This is just from some of the data that you gave me. I thought, well, you give me any data, I love to graph it. So I'm just showing the yields that James gave me the other day. You can basically see that P5, this is P5, you can see that one coming into commercial production. The other ones are sort of varying, a little bit of variation there, a bit of a trend I think maybe for biennial. I'm not sure whether you'd agree, but it looks to me like there's some sort of a trend in the background there for your crops that are showing a biennial trend. But of course that's a common thing within the industry. The sort of work that we do is looking at every depth level. So this sensor, or a longer sensor, will have this is a probe. This will have sensors every 10 centimetres. So every 10 centimetres it'll take a reading, and that's reflected up in that graph there. What we've done here is we've split the y-axis, this is called a separated level graph, so that you can actually tell the tracings apart. So this is at the 5 centimetre, 15, 30, 25, 35. And you can see at each depth where the water is and what's happening within that depth. And you can also see at various points, you can see how much water is being extracted from which depth in the root zone. So if the tree is drying out at the top, having trouble getting that water out, it'll turn on its lower roots, and it won't do it. It won't do it, but it'll do it straight away. It won't be shy about it. It basically takes out the water that's the easiest to get at the very surface, and then when that runs out, it'll start taking in the other water. And you can see here, actually this point's a good point. You can see an irrigation started, and then there was rainfall. So James probably went out there and said, turn the water off. We've got rain. So rainfall is much better than irrigation to actually infiltrate into the soil, and you can see it going quite deep. And that's a great point to actually see what our fall point is. You can actually detect how far that water went in within, say, a 24-hour period or 48-hour period. That water reaches quite a depth. So you can actually set levels, stress levels. So you can set a fall point and an onset of stress level to then use in subsequent times. So the sort of detail that you can get, this is data that's recorded in this. We do it every 30 minutes, I think. You can do it every minute if you want, but don't do it. It's a lot of data, and it just takes, it's just too much to handle. So every 30 minutes you can get these levels forever, if you like. I've had data in there that's 10, 15 years old. It's quite resilient. Another thing you can do, another example essentially of the same sorts of data, but in this case the growers had chosen to set the stress level, the wet level, if you like, the full point level, should vary over the season. So there's times at which you don't necessarily worry about the roots being completely flooded, but other times there are. So obviously you don't want to introduce disease into the roots, but you've got to sort of set yourselves reasonable full points and points, so you can work between those. The idea is to work within the green zone, stay out of the blue, stay out of the red, and we set a refill point. So a refill point usually fairly conservatively, so that you can say, okay, I can accept the drainage to go to something like back here. I can set my refill point there, so that I know where I am at any time of the year. And over the years, James and Martin have sort of worked at a method for setting, and it's like a signature, if you like, an irrigation signature for how much water should be applied when, depending on, of course, prevailing weather conditions. And you've got to expect that will change every year, change every month. So these sorts of things you've got to review all the time and keep up with. That's just an example of how you can easily get hold of your data. I know James is not too keen on keeping irrigation records of everything, so you can essentially just use the data to work out exactly how much you put on. So you can just set a ruler between a certain period and a certain other period, and work out what the water content is. So you can quite easily tally up exactly how much water you've had. This is at the 5 centimetres, so the sensor is reading at the 5 centimetres. It's reading all those peaks that you've had. So really useful for that. And that will actually set, well, in this case, it will actually record the irrigations plus the rainfall. You could put a rain gauge in there. We haven't done that yet, but we could put a rain gauge in there, and we could then subtract the rain from the irrigation if you wanted to. You can do all those things. Another thing that we like to look at is the fertiliser applications. So this is a seasonal fertiliser application. So this is if you look from the whole year from 2023 to 2024, you can essentially look at all the applications, the different fertilisers, the urea, the DAP, and the potassium sulphate there. And I've got, this is the water content, so these are all the water applications. This is just the top two levels. Sorry, there's a lot of detail in these graphs, but I make no apology for it because it can get more complicated or simpler if you want it. So the two different levels at the very top surface show the irrigations. I've also got the DIC, so that's the volumetric iron content. That's the salt moving through the soil, if you like. And at each time you can actually see, I've got this zoomed in on the next slide, but with these applications of different fertilisers, you can see different profile within the volumetric iron content. I'll go to the next one to give you more detail on that. You can look at things like, well, urea, it's essentially a covalent compound. It doesn't readily dissociate. It goes into microbes. Microbes then use it to grow, divide, and then they break away and they release a lot of ionic components, nitrates and nitrite, and ammonia. So it takes a little while for urea to go through its process before it's released and available for plants. Something like potassium sulphate or DAP dissociates readily, so you get a lot of ions released, and our sensor picks those ions up really quite well, quite readily. So we have a sort of an ionic here, ionic there, and a covalent, if you like. And what happens is that the urea sort of takes a lot longer to sort of infiltrate and get released into the soil, whereas the other ones, they sort of form spikes in the appearance of the bit, so the bit value reacts more quickly to those. But you can see essentially what we have here is at various times, there's an irrigation here, you can see a sudden drop in the Vic value. So there's a sudden removal of nitrate as it goes through the soil, and nitrate and other components, the other ions as well, the potassium and the calcium and sodium. So there's a sort of a leaching event, so fertiliser leaching at this point. So each one of these irrigations will cause a drop in the amount of nitrate. But that's okay because you've got more coming through. You've essentially got the urea, which is sort of the slow burn. It sort of carries on releasing, and then you've got these peaks of nitrate. So it's really nice to look at it in those terms. You can sort of see those relationships. So moving on to the canopy studies, Mahadevan and Brenda Cranes have been doing a study with looking at using tiny tag to look at the canopies.
Not really me, it's more Maha's work.
Oh, right, very good. I'm going to cross you out now. So this is it's nice work to be able to actually collaborate on something that we wouldn't have necessarily thought, oh, okay, this is something that we should get involved with. But to find out that somebody wants to look at this is great, because it sort of puts us ahead of looking at what the industry is looking for, looking to solve. So we have two tiny tag. These are little loggers that little SCI 12 loggers, I think, that you can put into a weather shield and then suspend in the canopy. And the canopy, I think it's 1 metre and 2.5, I might be right. And it's a manual download, and then we transfer that data into Irimax, our own software. So this is the sort of system we have. These are Maha's temperature sensor shrouds with the tiny tags in it. And we put in a similar system that we're going to put. We're going to elevate our shrouds as well. So we actually measure in the same tree, Maha. I think it's probably a good thing to do for a little while, and see what it gives us. So yeah, the system that we have is a wired-in system. It's a multi-system, but it's got two RTD temperature sensors in that. But I'll say we've got another idea for development of that. So this is Maha's data. We've got a region of lower and upper. So that's the lower sensor, that's the upper sensor, the one up at 2.5 metres, or 3 metres now, I think. So we have temperature and humidity. So we've just imported all of that data, and that's really valuable, really good stuff to have that there. We might be able to do many things with that. Another way of putting that data, I've just given a total, so I've just added it up over, I think it's daily, so daily increases, if you like. So you can see this right cool period here. I'm sure Maha's looked at that data too. We might even be able to introduce the calculation that you have for degree days or degree portions or chilling portions. We might even be able to plot that rather than the values for just temperature. So that's another idea to further this program. So essentially you can see this nice cool area in here where everybody's worried about in September that there might be a chill factor in there that's causing problems later on in dieback. So that's really nice to be able to summarise that data as quickly as we can and drill down on it. I've just put it in a slightly different way. This is essentially showing these panes. These are two different panes at the same zoom factor. So this is our temperature data for the top two levels. You can see the temperature values in the soil don't vary a lot. They sort of stay fairly consistent, but they do wax in and wax out with the seasons. So this is winter and then summer over here. So what I've prepared it as, this gentle, if you like, temperature changes that are occurring, and then in the canopy we've got the two two areas that Maha has had working, and I put them that this is 1 metre, the green, and the other one, the top one, is at 2.5 metres. So you can see the sorts of variation. Most of the variation is, of course, in the atmosphere, in the air. So that's probably where your problems are. You've also got perhaps some effect of temperature in the soil, depending on how much nitrate is absorbed. So nitrate has an optimum temperature at which it will enter roots. We use that a lot in potatoes to work out when you put your fertiliser applications. Better, during the night, so that in the morning when photosynthesis starts to kick in, you get a lot more nitrate taken up by the plant. You might be able to look at something like that in the starch area as well. Although in your case, you don't put a lot of fertiliser on in winter. But it might be another area of study that we should have a look at. But you can see there, near 0 degree days, these sorts of variations. 0 degrees to 37 degrees. There's this huge variation there, and we're expecting a lot from a plant to be able to handle that, particularly at certain times of the year when it's got gentle, juvenile shoots coming through. I'm not surprised that we see dieback. We're expecting the thing to grow in atrocious conditions, but we obviously want to do it for commercial reasons. We want to push it as far as we can. So understand that too. But that's nice to see it like that together. Progression of the project perhaps is what we're suggesting. We have a different sensor in mind, which is called the Thingy. A great name for a sensor. If you can't work out what to call it, we call it the Thingy. Well, it's the Thingy 52. It's a battery-operated Bluetooth device, essentially. So it doesn't require any cabling, any connections. And we can print these temperature shrouds for about $3.80 on the kitchen table overnight. And these sensors cost about $80. So you could put 5, 6 of those on a pole, these shrouds, and then we could actually collect the data using one of these. This is a hub. This is a Centec IoT probe that we've been working on and sort of released in the last 6 months. That records data from any Bluetooth device. It basically scans for Bluetooth devices and then collects that data together and shoots it up to the web. So we could do something like that. We can look at temperature, humidity. It also records air pressure, CO2, total volume, volatile organic content. So you could do all that if you'd like to. Colour, I wouldn't worry too much. That's more just if you're looking at leaf colour, maybe that would be something that you could look at cell size or something like that, or nitrogen content maybe in the leaf, and of course light intensity. So that might be a useful thing to have. So we're looking at those sorts of functions, but we'll let you know when we get that together. It also would help us in developing the Bluetooth. So I think it'd be something useful. This is just something I thought for interest. A lot of my work is teaching people, teaching uni students and whatever about the technologies that we have. I'm sorry it's in almonds, but we have a thing where you can do an array. So if you had, in this case it's 5 of these probes, 6 of these probes, going down to 60 centimetres, so in an array, so just spaced away from an emitter. And then what it does is does a 3D, it's 2D transect. So it does a calculation from one sensor to the next. It does the triangulation of that sensor to the next, and it assigns false colour images to it. And you can get something that looks, hopefully if it works, like this. So what it's doing is, get out of the way. So you've got a probe. Every one of these 20 centimetres has got a probe in it, and you can see the water content applied here. So this is a drip emitter. It's been applied there, and you can see how it balloons out and starts to get dried out by the root mass. So the root mass is all in here. It's extracting all that water, and this is the interrow, so that stays fairly dry. That's just, the sward of the grass uses the top bit, and the whole area sort of stays fairly dry. But you can use it as a good example of how water actually does move. It's real data because it's collected from a probe that's in the ground, and you can see over a time period. This time here is just ticking away. This is over, I think it's over a month. You can sort of track that change in a really demonstrative way to show where the water does go. So you can really get an idea of how much water you're putting on, how long it takes that water to be completely removed by the plant or moved transversely or
That's drippers, isn't it?
That's drippers, yes.
Well, that comes all green in the middle.
Yeah, it's northern hemisphere. You've got railroad drippers, so there's 2 drippers. We've got 6 probes leading out into the interrow. Don't ask me how we got permission to do that, and a tractor going through all the time. We didn't lose any top caps, which is amazing. The sward there, they actually planted that sward, for the experiment really, but to try and dry things out a little bit to sort of see some contrast. And obviously it's during flowering season at the time, so it's really nice. So yeah, but we can do that. Well, we do that for potatoes. We do that for anything. You can do it for anything that you want. I've got a good one in apples. We've done watermelons. We've done many of these crops that are just great teaching tools for students to understand that as soon as you put water on. You don't have to put it on straight away again. It gets into the soil, the plant uses it, just wait. Wait and have a look, because, just because you kick the dirt and it looks dry, it doesn't mean that it's dry out throughout the profile, because water moves through it strange ways in soil.
What's the distance between those probes there?
20 centimetres.
Oh, right.
Yeah.
Jeez, it don't go out far then, does it?
No. It's in that soil type. It's a heavier soil type, but if it was, the sand, the water sort of goes straight down. In a clay, it just sort of goes. I don't know what I'm going to do. It just doesn't move very quickly. But in this case, it's sort of sandy loam, really. They're lovely. You can watch them for hours. I do. No. You can tell my enthusiasm. Well, before you say yes to that, they're $1,200 a probe, so 6 of them. It's an expensive experiment. I think it's worth it. I think you demonstrate to a lot to that experiment. I've shown that all around the world, and people are very interested. Okay, so my conclusions. Intensive monitoring really, I think, is the way to go. We've got to be thinking about, if it was simple, it would have been done yesterday. Obviously, this problem is a difficult one. I think we need to collect a lot more data in a lot of different ways, and try and put it all together. It's not going to be easy. Don't expect the result next year. But it'll be coming. So soil trending we've used it for years, indicates the plant physiological responses. Basically we use the plant as the sensor. The sensor is the plant. It tells us what's happening with the water, and when we can see that, then we can interpret and understand the plant. If we can do that, then it's training ourselves. We're the idiots. The plant's fine. We've got to be trained by the plant. So multi-factor monitoring, I think, is the way to go. My last slide is one of my favourite cars on on your property. So what we need to do next essentially is install more temperature and humidity sensors. That's what we're getting to. I think we need to get some sort of a standardised photograph, maybe a station there that we can actually photograph the same spot every time we come, every time you're there, maybe twice a day, no, maybe once a week, something like that would be really good, because if it does have dieback in the tree that we happen to be photographing, we'd be laughing, and Maha would be writing it up in a publication and accepting the grant money. So that's the way. We need to maintain the data stream, and obviously we've got to get continuous data for that sort of study. Of course, we need some records on disease watch and spray records as well. We've got to be sure of those things. I think that's my last slide. Yeah, that's it. Are there any questions?
What depth are the volumetric ion sensors, the monitors which you showed in the fertilizer slide? Volumetric ion sensors. So the volumetric ion sensors which you showed in some graph. So at what depth are they from this?
They're at the same depth. You got a mini? They're at the same depth. So each one of these sensors is a reduced one of that. It's smaller, sitting there, and that will record the volumetric water content, volumetric ion content, and the temperature.
Okay.
So there's one there.
All the three comes on one.
This is the 30 centimetres, so it's got 3.
3 within 30.
But the 120 has got 12.
Okay, so the ones which you showed is up to 120, or is it?
They were 120 and 60.
120 and 60. Okay. And okay. Thank you.
So
The one that your sensors are is only 60.
Only at 60. So you have more sensors sitting at 60.
6 sensors on that.
Up to 60.
Yeah.
Okay.
Because the ground's too fast.
Yeah. And when you say installing more temperature, humidity sensors in the canopy, what do you mean? Like how many sensors do you want in the canopy?
I would like to have every 50 centimetres.
Every 50 centimeters, like the way I have, but I got it at an interval of 1.5 meters, like, and so you want it every 50 centimeters.
Every 50 centimetres from the ground. Yeah. That would only be 6 of those thingy sensors.
Oh, thingy.
It's going to cost you $480.
And that can be remotely downloaded, the data.
And remotely download the data.
Okay.
You'd be downloading the data and looking at it and laughing while I was not getting to it,
So, question on the leaching.
Yeah.
So, you said you saw some maybe nitrogen or something you were really leaching. How do you know how much is leached and how much the plant's taken up?
You don't.
That's what I thought. So it is.
You don't. Well, you can, but we've got some researchers that have done something similar in New Zealand. They're working with sand, where they know that they've got nothing but soil, it's just sand, it's a big sand, and they apply potassium nitrate to it. So they assume that the results that they see are all to do with nitrate and potassium, which is a fair assumption. The sand that they're using. So in this sort of soil type, no, you don't know. It's more complicated.
Yeah. So
If it goes beyond 65 to 70 centimeters below the then that's gone. So
I just know there's a few fertiliser people who get charged a minute. They just don't want to waste it. That's all.
Yes.
Yeah, we have potato growers that use the TriScan to work out how much irrigation they use and how much fertiliser they use.
We've got a lot of your Semtech, but for irrigation, I don't think we've got anything for.
We've got some trucks.
Yeah. We need someone who may water change it.
Well, I'm not here to sell. I'm here to talk about it. Any other queries?
So it talks from Bluetooth doesn't go very far, so it goes to another thing and then talks to the cloud or something. Is that the way it works?
Yeah, it's only 5 metres, well, reliably, which is probably 18 metres on a good day.
Yeah.
But 5 metres reliably, just to the station and pulses it out through the web. Essentially, it's a mobile phone.
Yeah, so you've
it's a
got-
circuitry with a mobile phone and a battery.
So have you all 4G?
Yeah, they're all 4G now. Yeah, used to be 3G, and then someone said, "Oh no, we're taking 3G off." Oh, thanks.
Do I
They
need a
gave it
modem?
12 months notice, so
I'm still trying, I've got a green brain, I'm still trying to change to 4G. The government's funding half of it, I'm waiting for the government.
Well, they tell you they're going to turn it off.
Because the people in the bush are complaining, that's why they.
You're complaining because we all try, but they haven't got enough time to help replace all these systems.
Do I need a modem? Do I need a modem at the site to be able to transmit the data
Yeah.
and collect where I am?
Yeah, that'll be that system there. That IoT We've got a vested interest in it. We want to contribute, and it's going to lead somewhere. Helps us, helps everyone.
How do these probes compare to EnviroScan? Are they like a budget version of the EnviroScan, or are they a better version?
That's a
They
good
seem,
one.
they're cheaper by the sound, but they seem
They
to...
are. Yeah. I suppose they are a more budget version, but they are probably more robust because, as you saw, they're like a broomstick. You know, they're solid. They're full of epoxy material. So put the circuitry in there, and then we fill it up with an epoxy, and that sets. So the whole thing is like a tight glue, and that you can whack James on the head with it and knock him out, and it'll be, and it won't be damaged. James will be.
And they seem to sense more things than an EnviroScan as well, or
Yeah, they read the same.
it's the same.
Yeah, they use the same calibration equation, in fact, to.
So
to
can you
value.
incorporate them into a system that's already got EnviroScans in it? Like, is it compatible with the same software and that sort of stuff?
The Bluetooth, you'd have to change some of the circuitry. We have a thing called the all-in-one, which does the same thing as the Bluetooth that I showed you. It has a modem attached to it, but it's a larger headpiece, essentially the larger cap, because it's got to accommodate a modem plus a battery plus the interface, so it's a larger cap. So you can upgrade from whatever you have. If it's a hardwired EnviroScan, you can upgrade to an all-in-one.
So do you think this will supersede the EnviroScan and they'll get rid of that eventually, or what's the...
I hope not, because the EnviroScan is well, I think it's still superior, but because you can service it. You know, you can go back if one of the sensors breaks. You can go and pull the sensors out, fix that sensor, and put it back in again. Whereas with a drill and drop, if one of those sensors fails, then you've got to replace the whole probe.
What about in regard to how it reads in that? Would you say the EnviroScan is superior in regard to the data that it collects?
Yeah, it is. It's slightly. The root mean squared error for an EnviroScan is 0.01, and for a drill and drop it's 0.02. It's only tiny, but for a scientist it's it's a real thing. So yeah, not for a grower. A grower wouldn't care. They're only worried, it's not going to make much difference to, if you're reading 1 millimetre of moisture, whether you're reading 1.01, it's not going to make any difference. But for a scientist, you want to be sure of that.
See you all. Where you get home?
Safe travel.
So, were there any more questions, Michael? So, thank you so much, Michael. And thank you to the Stepfendorf a good trial site that's of benefit to everybody. So a big thank you to everybody for coming today and participating with good questions and general interest in the points of discussion. Just a few little things to wrap up. So there will be a QR code here in a moment. We really appreciate your feedback for your own sake. Then we can develop programs that are meeting your needs more effectively. Those of you who are coming tomorrow for the University of Melbourne, what do you call it again, please?
Sunny TAFE.
The Sunny TAFE
Yeah.
tour. Sorry, the Sunny TAFE tour. If you haven't registered yet, please see Kelsey, because you have to go through and tick all these boxes, and it's much easier if you do it on her phone. So that would be good, because we can't all get in until everybody's done it. So please see Kelsey if you haven't. The next pick group, I believe we've established today, it's going to be at Bob Hodgson's place. Thank you, Bob. It's really great. And then we'll be probably putting someone like Chris on the spot, or someone like that, not necessarily Chris, but maybe, for the other farm. So we'll see about that. You'd be very good at poker, unlike me. So yeah, that will be sometime in November. The date is to be determined, but just watch this space, probably late November. I think we've got a date that's tentatively set for the 23rd of October 2025 for the next Grow Forum and Annual General Meeting. It will likely be in Mildura. It may not be here. We'll see. Kelsey will do some research on what the alternatives are. And really, I think that's what I wanted to say. So yeah, please, if you could do that, even if you take that and then fill it when you've left, we will get it electronically. So really appreciate Kelsey and Maha and Chris and all of the committees and just your participation. So really appreciate it, and wishing you all a safe trip home. And please take your name tags off and leave them on that front desk there so that we can reuse them. And yeah, farewell for now.
Thank you.
And that's how you do it.